Welcome back. In this video, we are going to solve problem 12-48 that is taken from chapter number 12, Deflection of Beam and Shaft, and book name is Mechanics of Material by R.C. Hibbeler. So statement is the wooden beam is subjected to the load shown. Determine the equation of elastic curve. Specify the deflection at end C. E of wood is 1.6 into 10 raised to power 6 ksi. So you can see this is the wooden beam that is overhanging beam, and from point A to B there is a triangular load or uniformly increasing load that is 0.6 kips per feet, and at point end C we have 1.5 kips load. The cross section of this beam is shown. Width is 6 inch and height is 12 inch. So let's start with the solution. So we have to find equation of elastic curve, and we have to find deflection at point C. Deflection at point C, which is equal to VC. So solution is, the first step is that if you remove this reaction, if you remove the support at point A, so you'll be having reaction force. Let this is in downward direction, and this is RA, and if you remove this roller support at point A, so you'll be having reaction force in upward direction, that is RB. So you can take it as per your own convenience, and from the answer you will judge it whether you have taken the right direction or not. So let's start finding RB. So RB can be obtained by applying the equation of equilibrium, that sum of all moments about point A is equal to 0, taking the counterclockwise moment as positive. So you can see there is a triangular load of 0.8 kips per feet. If we convert this triangular load into a point load, so this is a triangular area, so it can be obtained by formula 1/2 into this 0.8 into the length over which it acts, and that is 0.9, and that is equal to 3.6, and that will be act at a distance of L by 3 from this denser side. So L by 3 length is 9, so L by 3, 9 by 3 is 3 meter, and this remaining distance will be equal to 6 meter. So a moment about point A is produced due to this load, and perpendicular distance is 6, and this is producing clockwise, so it will be negative. So I will write 3.6 into perpendicular distance is 6. The second moment is produced due to this RB into perpendicular distance is 9 feet, and this is producing counterclockwise, so it will be positive. So I will write plus RB into 9. The third moment is produced due to this load 1.5 kips, and perpendicular distance is 18, and this is producing clockwise, so it will be negative. So I will write minus 1.5 into 18 is equal to 0. So I will get minus 21.6 plus 9 RB minus 27 is equal to 0. Okay. So 9 RB will be equal to 21.6 plus 27, and you will get RB will be equal to 21.6 plus 27 is actually 48.6, and if you divide 9 on both sides, so you will get RB will be equal to 5.4 kip. Now you have this RB clear. We can find RA by using another equation of equilibrium, that sum of all forces along y direction must be equal to 0, and upward force taken as positive. So RA, which is downward, so minus RA, this force 3.6 that is downward, so minus 3.6 plus 5.4 is RB minus 1.5 is equal to 0. So again, when you calculate it, you will get RA is equal to 0.3 kips. Since this is positive value, it means that you have taken the correct direction of reaction force RA and RB. Now you can see We are interested to find out equation of elastic curve that can be obtained by using this formula. EI into d square V over dx square is equal to moment, and this moment can be obtained by using Macaulay's method. Okay, so we'll apply Macaulay's method to find out this moment m. Now you can see here from this figure that there is a point load, there is triangular load, point load, and again point load. So we will start from left hand side and we will move toward right hand side, and at right hand side you will neglect this force. Also the loading is shown in the table. For point load we will use the moment equation, this one, and for this load, triangular load, we will use this equation. Okay, if you look at 4 number, this triangular load start from anywhere but it is till the end, and this here this load start from A till B. So what we will do is we will add further load over here and we will convert it into triangular load like this, and at the end we will subtract the same load but in the opposite direction, so that we can easily apply this table. So I will draw the free body diagram over here. So this is the beam, this is your point A, where is a load of RA is 0.3 kips, clear, and at point B we have a load of RB, that is 5.4 kips. This distance is 9, clear, 9 feet, and the remaining distance is also 9. Okay, so from what we will do is that we will add this load from first point till the last end. This was the load till this, and that is 0.8 kips per feet, that is triangular load downward, and you can see this is over length of 9 feet. So this is again 9 feet, so this load will be double, so it will be 1.6 kips per feet, and that will be downward. What we have done is that we will add this load 0.8 and this load in the opposite direction, so it should cancel the effect. So we will choose another color. This is 0.8 kips per feet, so from here and then till the last here the load is 1.6 kips per feet, and this should be in upward direction. Okay, now you can see this 0.8 is, if we treat it like uniformly distributed load, so till this it will be 0.8 kips per feet, and from here it will be 0.8 to 1.6, and at the end we have a point load of 1.5 kips as well. So this is 1.5 kips load. Now apply this moment equation. So this moment M will be equal to, the first load is this 0.3 kips and that is acting downward, so this moment equation will be -1. So I will write this moment is equal to minus 0.3 into x minus a is equal to 0, because this load start at the beginning, so this will be minus 0.3 into x minus 0. The second load is this uniformly increasing load, and you can see for uniformly increasing load the moment equation is this one, where m is the slope. So we will find this m. So this m will be equal to perpendicular, which is 1.6, divided by base, which is total 18. So this is m. So this load is upward and this is downward, so I will write minus m by 6. So m by 6 is 1.1 by 6 multiplied by m, which is 1.6 divided by 18 into the x minus a. So x minus a is equal to 0 for this load, so x minus 0 power 3. The third load is this load, which is 5.4, and this is upward, so we will use this equation. So plus 5.4 into x minus a is 9 for this. So x minus 9 power 1. The fourth load is this uniformly distributed load of 0.8 kips per feet. So distributed load is like this. So I will write this load is upward, so it will be plus W naught is 0.8 divided by 2 into x minus 9 power 2. Okay, and the last load is this uniformly increasing load that start from 0.8 till 1.16. So slope m for this will be equal to perpendicular, which is 1 point. This is again this height, this remaining height will be 0.8. So 0.8 divided by this base, which is 9 feet. So this will be the m. So m is equal to 0.8 divided by 9. And you can see this load is upward, so this will be positive. So plus m, which is m by 6, so 1 by 6 into m is 0.8 divided by 9 into x minus a. A for this is again 9. This 9 power 3. So this is your moment equation, and if you simplify this moment equation, you will get minus 0.3 times x minus 0.0148 x cube plus 5.4 into x minus 9 and plus 0.4 times x minus 9 square plus 0.0148 into x minus 9. So this was the most difficult step in this problem. This is your equation number A. Now it's very easy. Put the value of m in equation A. Put value of m in equation A. So you will get EI into d square V over dx square will be equal to minus 0.3 times x minus 0.0148 x cube plus 5.4 into x minus 9 plus 0.4 into x minus 9 power 2 plus 0.0148 into x minus 9 power 3. So what we will do is that we will integrate this equation. Integrate it, you will get EI into dV over dx will be equal to minus 0.3 x square over 2, which will give you minus 0.15 x square. The second term minus 0.014 x power 4 divided by 4, and this will give you 0.003703704 x power 4 plus 5.4 into x minus 9 power 2 divided by 2, which is equal to 2.7 into x minus 9 power 2 plus 0.4 into x minus 9 whole cube divided by 3, which will be equal to 0.1333 into x minus 9 power 3 plus 0.0148 x minus 9 power 4 divided by 4 will be equal to 0.003704 into x minus 9 power 4 plus C1, which is the constant of integration. This is your equation number 1. Now integrate this equation 1. So you will get EI into V is equal to minus 0.15 x cube divided by 2, which is equal to minus 0.0 minus 0.15 x cube divided by 3, which is equal to minus 0.05 x cube minus 0.003704 x power 5 divided by 5 will give you 0.0007407 x power 5 plus 2.7 into x minus 9 power 3 divided by 3 will be equal to 0.9 into x minus 9 power 3 plus 0.133 into x minus 9 power 4 divided by 4 will give you plus 0.3333 into x minus 9 power 4 plus this will be equal to 0.000747 into x minus 9 power 5 plus c1x plus c2. Let this is your equation number 2. Now c1 and c2 are unknown constant, and by using boundary condition we will find these two, C1 and C2. So what are the boundary conditions? So first boundary condition is that at x is equal to 0 we have deflection is equal to 0. So let me show you over here. You can see at x is equal to 0 we have deflection is equal to 0 because there is a pin support at point A. So what we will that put in equation number 2. So when you put it in equation 2, so this will be 0 because v is equal to 0, this will be 0, x is 0, this will be 0, minus 9 inside the Macaulay bracket will be considered as 0, this will be 0, this will be 0, c1 into x will be 0, so we will left with c2 is equal to 0. So c2 will equal to 0. So you have to perform this step so that one can understand. Now the second boundary condition is that at x is equal to 9 feet, we have v is equal to 0. So let me show you again. Here you can see at x is equal to 9 feet, we have deflection is equal to 0 because there is a roller support. So put in equation number 2. So EI into 0 is equal to minus 0.05 into 9 cube minus 0.000747 into 9 power 5 plus 0.9 into 9 minus 9 power 3 plus 0.03333 into 9 minus 9 power 4 plus 0.0007407 into 9 minus 9 power 5 plus C1 into 9, which is 9C1, and C2 is equal to 0. So this will be equal to 0, this will be minus 36.45 minus the second term will be 43.74, this term will be 0, this will be 0, this will be 0, so plus 9 times C1. So from here you will get C1 will be equal to 8.91. Now you have C1 is equal to 8.91, and what we have been asked to find, so equation of elastic curve and deflection at point C. So what we will do is that put the value of C1 and C2 in equation number 2, in equation 2, and divide EI on both sides to get the equation of elastic curve. So you will get V is equal to 1 over EI into minus 0.05 x cube minus 0.0007407 x power 5 plus 0.9 into x minus 9 power 3 plus 0.0333 into x minus 9 power 4 plus 0.0007407 into x minus 9 power 5 plus C1. C1 is 8.91 x1 and C2 is equal to 0 is required equation of elastic curve. So this is equation of deflection. So if you want to find deflection and at any x distance, so put the value, you will get the deflection. In our next part, we have to find deflection at point C. So at x is equal to 18 feet, so deflection is equal to VC. So put what we will do is that put x is equal to 18 feet. So what we'll do is that in above equation of elastic curve, you will get v is equal to 1 over e into I, and that will be minus 0.05 into 18 cube minus 0.000747 into 18 power 5 minus plus 0.9 into 18 minus 9 power 3 plus 0.0333 into 18 minus 9 power 4 plus 0.000747 into 18 minus 9 power 5 plus 8.9 into 18. So when you solve this, you will get this V, that is displacement at C, will be equal to 1 over EI times minus 612.36, and the unit will be kips into cubic feet. Now we have been given that E of wood is given as 1.6 into 10 raised to power 3 ksi, and the cross section of this beam is given as, so we will find I. So I is equal to 1 over 12 bh cube. So 1 over 12 into b is 6 inch and height is 12 inch cube. So we will put the value downward. So from here 1 over E of wood is given as 1.6 into 10 raised to power 3 ksi. So 1.6 into 10 raised to power 3 ksi into I is 1 over 12 into b was 6 and height was 12 cube. So it will be inch power 4. Multiply by minus 612.36, and we will convert it into feet, inch. So there is feet, so 1 feet is equal to 12 inch, so 12 cube. And when you solve this, you will get VC will be equal to minus 0.765 inch. Or you can see that VC deflection at point C is 0.765 inch, and that is downward. So this is the answer of our second part. And that was all about this problem 12-48. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it, and don't forget to press the bell icon so that you can get notification about my latest video. Also comments on my videos whether you like it or not, and if you want to suggest any improvement, you can tell me in the comment section. Thank you for watching.